Okay, so picture this. You're scrolling online, right? Just looking for, I don't know, some light reading, maybe about, I don't know, the history of pizza toppings or something.
Okay.
And bam, out of nowhere, you stumble upon this whole community, and these people believe, get this, they believe the Earth is flat.
Seriously?
Yeah, I know.
People still believe that.
Right, that was my first thought, too. But, you dug up some pretty wild sources for this deep dive, and honestly, the more I read, the more this whole thing felt, I don't know, less like a joke and more like a puzzle I wanted to solve.
Yeah, I get that.
So today we're diving headfirst into the surprisingly complex world of flat Earth theory.
All right, let's do it.
And just to be clear, this isn't about, making fun of anyone. It's about understanding, like what's really going on beneath the surface. You know what I mean?
Absolutely.
Okay, so you know me. I love a good head scratcher.
Yeah.
And you definitely delivered with this first source.
Oh, yeah.
An excerpt from a paper called, get this, The Mathematics of the Infinite Flat Earth.
The Mathematics of the Infinite Flat Earth.
Yeah, Infinite Flat Earth. Who knew?
Right.
Who knew that was even a thing?
It's a whole thing. What's interesting about this paper, though, is that it's less about actually proving the Earth is flat and more about, well, it's more like exploring a hypothetical scenario, kind of like a mathematical what if, but using some pretty high-level concepts to do it.
Yeah, I felt that.
Yeah.
I will fully admit that when I hit that part about Gauss's law and closed surface integrals, I definitely had a flashback to every single calculus exam I ever struggled through.
The flashbacks are real.
They're so real. But okay, before we really get lost in the weeds here with the math, can you give us the layman's version?
Okay.
What was this Gauss guy all about? And how does it connect to gravity on an infinite plane?
Yeah, totally. Okay, so imagine a light bulb, right?
Mm-hmm.
The closer you are, the brighter the light. Simple enough.
Mm-hmm.
But as you move away, that light spreads out, right? Gets dimmer.
Right.
Gauss's law is basically a way to measure that spread, that intensity.
Right.
And the key here is it applies to gravity too. Gravity, just like light, gets weaker the further you travel from the source.
Okay, so far so good. But this paper takes it a step further, this whole closed surface integral thing, right?
Yes, exactly. Think of it this way. Think of it like measuring the flow of water through a pipe. A regular integral might tell you how much water is passing, like a single point in that pipe, right?
Mm-hmm.
But a closed surface integral that measures the total flow, across the entire pipe surface.
Okay.
This paper takes that same concept and they apply it to gravity.
Okay.
On this hypothetical infinite plane. They're essentially trying to calculate the total gravitational pull, but coming from every single point on that endless surface, it's kind of mind-blowing.
And what I find so wild is that they're suggesting that it wouldn't even be this infinitely strong pull that sucks everything into oblivion.
Right.
Which I feel like would be my first concern.
It's wild. The math they're using, it actually suggests that with the right setup, the forces on this infinite plane, they could actually balance out.
Really?
Yeah. In a way that creates finite gravity, just like we experience here on, our very much round Earth.
Right, exactly. And that's what I find so fascinating about this. It's not just the math itself, which, don't get me wrong, is impressive.
It's pretty impressive.
But the fact that someone, felt compelled to create this mathematical model in the first place, for a concept this out there, it makes you wonder, what's driving that kind of, I don't know, dedication to an idea that on the surface seems, so out there?
It really speaks to, I think, a deeper human tendency, this desire to find alternative explanations, to question, what we think we know. And honestly, that's something that ties directly into, the whole world of conspiracy theories, right?
And that's a perfect segue, because our next source dives headfirst into that world.
Oh, does it?
Oh, yeah, big time. You included this BBC News article about, modern-day flat earthers, and I have to say, this article was a wild ride.
Yeah, this mathematical paper, it really highlights how some people, they try to rationalize their beliefs,
Right.
But we're going to see in this BBC article, the reasons behind these flat Earth beliefs, well, they often go way deeper than just making the math work.
Yeah, and it's not like everyone who buys into this idea fits into one neat little box.
Yeah.
The article makes it clear that even within the flat Earth community, there are tons of different ideas about how this whole thing is supposed to work.
Oh, totally. And the article talks about how some people, like this guy, John Davis, they're more into that infinite Earth idea. But then you have others, they're sticking with that more, I don't know what you'd call it, classic.
Right.
That classic disc-shaped model. Yeah. It just goes to show that even within what we might see as this like fringe group, there's still room for different interpretations, disagreements, all that.
Totally. And this John Davis, his perspective, it really stuck with me. The article quotes him saying, "We humans seem to be pleased with just accepting what we are told, no matter how much it goes against our senses." It makes you think, right? Like, what's the root of that? Is it like a distrust of authority, or maybe this feeling like there's some secret knowledge out there, and only like a select few are in on it?
It's such a good question, and I think it really speaks to that very human need, that desire to find meaning, to feel like, I don't know, like we're in the know.
Yeah.
And conspiracy theories, I think they offer that feeling of having access to like these hidden truths.
Yeah. And for some, like James McIntyre, he runs a Flat Earth Society website, these truths can get, well, pretty out there. The article quotes him talking about Antarctica.
Okay.
As this like giant ice wall, right? Holding back all the oceans, which is, I think, like a pretty common belief in the flat Earth world.
Yeah, it's a big one. And as wild as it might sound to like you and me, for the people who believe this theory, it's a central piece. It's how they explain why nobody's ever just like fallen off the edge of this disk.
Okay, so can we address the elephant in the room?
Please.
All the evidence that, kind of disproves this. I mean, we have pictures from space.
Right.
So how do they get around that?
You've just hit on one of the most fascinating parts of this whole thing. The article, it mentions that both Davis and McIntyre, they think those images are fake, like completely fabricated.
Wow.
Part of some big scheme orchestrated by who else? The government and like all the space agencies.
Wow. So you're talking about like a deep fundamental distrust of these institutions, even when there's, what seems like pretty undeniable proof. That's kind of unsettling.
It is. And honestly, I think it speaks to a much bigger trend that we're seeing everywhere, this trend where information, it's everywhere, right?
At our fingertips.
Constantly. But trust is like dwindling.
Yeah.
And that makes it so much harder to have like real genuine conversations about these really important topics, especially when you're talking about like science and data.
Right, exactly. It really makes you stop and think,
It does.
Like beyond just arguing about, is it round, is it flat?
Yeah.
What can we actually learn from all of this? There's something bigger here, right?
Oh, absolutely. I think for me, it really highlights how important critical thinking is.
Okay.
And I don't just mean like immediately dismissing something just because it sounds strange.
Right.
But really making that effort to like engage with ideas that are different from our own. Even when those ideas at first glance seem a little, I don't know, out there.
Okay, so not just going, oh, that's crazy, but like really trying to see where someone's coming from, even if we don't end up agreeing with them.
Exactly. And remember, for a lot of these flat earthers, it's not about like a lack of intelligence or anything.
Right.
It's about this like deep need to question, I don't know, like systems of knowledge that they maybe see as flawed.
Right.
They're searching for explanations that make sense to them, even if those explanations, might go against what, science is telling us.
And that questioning, that in itself, that's not necessarily a bad thing, is it? I mean, we learn by challenging assumptions.
100%. It all comes down to how we approach the evidence. Are we open to hearing different points of view? Are we willing to actually look at the evidence objectively?
Yeah.
And maybe even, the hardest part, be open to changing our minds.
Yeah.
These are big questions, and they're questions we should all be asking ourselves no matter what we're thinking about.
It makes you realize, we all have our own versions of those flat Earth beliefs, right? Those things we hold on to, sometimes, really strongly, even if the evidence isn't really there to back it up.
It's so true, and it's humbling to think that even now, with all the information in the world, we all still have our blind spots.
Right.
We might laugh about this idea of a flat Earth, but what are we holding on to? What are our flat Earth beliefs?
Whoa. Okay, so as we wrap up our deep dive today, here's something for everyone listening to ponder.
All right.
If something like a flat Earth, something that seems so, far-fetched, if that can get people fired up, what does that tell us about how we form our own views about the world?
Big question.
And maybe even more important, are we brave enough to actually examine those beliefs, challenge ourselves, be open to, like, actually changing our minds when we see new information. Just something to think about as as you navigate the world out there, which, let's face it, can be pretty confusing sometimes.
It can.
Thanks for joining us on this deep dive.
Thanks, everyone.
And until next time, keep exploring, keep asking those tough questions, and keep an open mind.